Hello everyone. I'll be explaining to you about Hamiltonian cycle in this video. So if a connected graph is given, it can be either directed graph or a non-directed graph. We start from a vertex and visit all the vertices exactly once, and we need to return back to the starting vertex and hence forming a cycle. If such cycles are formed, we call it as a Hamiltonian cycle. That is, we have a graph here and there are set of vertices and edges. We start with a particular vertex. We travel along the graph, visiting all the nodes of a graph and reach back to the starting vertex. If it forms a cycle, we call it as an Hamiltonian cycle. In Hamiltonian cycle problem, the objective is to check if there are any Hamiltonian cycles in a graph. There can be more than one Hamiltonian cycles. So if there are more than one Hamiltonian cycle, we need to find all the Hamiltonian cycles in the graph. Now, if we notice this, it looks similar to our traveling salesman problem, which says that start from a city, travel along all the cities exactly once and reach back to the city. But the difference between the two problems is in traveling salesman problem, it is a minimization problem. So we need to find the minimum cost of starting from a city, visiting all the cities and returning back to the city. But in Hamiltonian cycle, we are finding all the possible Hamiltonian cycles in the graph. So that is a difference between the two. Now let's see one example. So we have a graph given here. So we are trying to find if there is any Hamiltonian cycle in this graph. So if we start from 1 and then move to 2 and then go to 3, 4, 5, 6, 7 and 8, we need to come back. We have to travel all the vertices and come back to the starting vertex. From 8 there is no direct path to 1. There is a path from 8 to 2 and 2 to 1, but we cannot visit a node twice. We need to visit a node exactly once. So this path is not possible. So we need to find such path which can form a cycle wherein I am visiting all the nodes exactly once. So we'll see whether we have any cycles like that. So we can start from 1 and then go to 2, move to 8, meet 6, visit visit 7, then 6, after that 5, go to 3. There is a path from 3 to 2, but if you move from 3 to 2, you will be visiting the node 2 twice. So I cannot visit a node 2 twice, but there is a path from 3 to 1 which will help me reach back to my original starting position. Now if you notice this, I have visited all the nodes that is given in the graph exactly once and I am reaching back to the node where I have started with. So this is a Hamiltonian cycle. We'll see two more examples to see whether there are Hamiltonian cycles in the graph. Now if you see this graph, if I start from 2 and start from 1, go to 2 and go to 3, then visit 4, I have to come back to 2 because in this case 2 is a connecting point between the to the sections of the graph. So this connecting point we call it as an articulation point. So if there is a graph wherein there is an articulation point, it cannot have Hamiltonian cycle. Similarly, here I have another graph wherein there is something called a pendant vertex. So if there is a graph with pendant vertex, there cannot be an Hamiltonian cycle in this graph. Okay, so your objective is to find if there is an Hamiltonian cycle in the graph or not. If there are, how many are there? If it is one or more than one. Again, I'm repeating, there can be a directed graph or it can be a non-directed graph, but make sure that the graph you are taking is a connected graph. That's all about Hamiltonian cycle.